Okay, so today's notes are on square roots and radicals, and our content objective is to rewrite expressions involving radicals and rational exponents using the properties of exponents. Our language objective is to use the correct terminology to describe radicals in the process of simplifying them. So let's start by talking about what radical notation is. So we are going to focus specifically on square roots, but radical notation is used for all sorts of roots. So it's written something like this. We have a number n that goes in the index, or what is called the index right here, that tells us what root we're taking. So it might be the second root, it might be the third root, or cube root, or the fourth root. But the index here, what's in the little check mark, tells us what root we are taking. What we are taking the root of is called the radicand. So our index is n, our radicand is a, and then our radical symbol is the actual checkmark looking thing with the line on top. That is our radical symbol. So what some of you might not be familiar with is the fact that our index, when we're working with square roots, is not always written. So our invisible index is 2. So when we're taking the square root, we don't always write that number. So the square root is written like this, and our square root of something like x squared is equal to x, or plus or minus x. We'll talk more about the positive or negative values later on, but for now, the key thing I want you to remember is when we don't have an index written, it implies that it is 2, or the square root of the number that we are, of the radicand. So why are we talking about this? We're first going to go over the multiplication property. Of square roots, because this is going to come up as we begin to continue working with quadratics. Since we're working with squares, we're going to end up using square roots to solve out. So we're going to review that to figure out, so that we can properly solve different quadratic expressions and equations. So the multiplication property of square roots says that for any numbers where a is greater than or equal to 0 and b is greater than or equal to 0, the square root of a times b is equal to the square root of a times the square root of b. So what that means is if you're multiplying two numbers under a radical, you can separate it into two terms being multiplied. So we'll do a quick example with that. I want us to simplify the square root of 50. So to simplify the square root of 50, you're going to first separate into factors with at least one perfect square. So not all radicals will be able to be simplified, but many will have terms that you can set, or factors that are perfect squares that will allow us to simplify. So I'm going to take the square root of 50 and I'm going to break it into two factors. So I know one factor of 50 that is a perfect square is 25. So I can say 25 times 2. So I can break my 50 into two factors, and then I can separate that into two different radicals. So instead of writing it as the square root of 25 times 2, I can write it as the square root of 25 times the square root of 2. So I'm going to separate into two radicals. And then simplify. So at this point, the square root of 25 I know is 5. So I'm left with 5 times the square root of 2. And that is my simplified expression for the square root of 50. So let's do some quick checks really fast. To the bottom of this page, we'll do a couple of quick checks. I want you to simplify first the square root of 300, and then second the square root of 32. So pause that, try that on your own, make sure it makes sense. I'm going to go over it now. So I'm going to separate the square root of 300. I know 100 is a perfect square, so I'm going to do 100 times 3, which then I break into my two radicals. So square root of 100 times the square root of 3. Square root of 100 is 10, so I end up with 10 times the square root of 3, and that is my simplified expression. Here, I know 16 times 2 will give me 32. So I can break that into the square root of 16 times the square root of 2, which becomes 4 times the square root of 2. So that's my simplified expression for the square root of 32. All right, so there's one more property we're going to talk about, so I'm going to flip the page to go over that. It's the division property. Of square roots. And that says that for any numbers where a, again, is greater than or equal to 0 and b is greater than or equal to 0. So just a quick note, they have to be greater than or equal to 0 because you cannot take the square root of a negative, because there's no way that a negative times a negative could equal a negative. A negative times a negative is always a positive. So you can never take the square root of a negative number. It's not possible. You end up with imaginary numbers. We'll talk about those later in this unit. So for all these properties that we're discussing, a and b have to be greater than or equal to 0. But back to the point, the division property of square root says the square root of a over b, again, is equal to the square root of a over the square root of b. So again, if you're dividing, or if you're square rooting terms that are being divided, you can break it into two terms, each being square rooted, or taking the root of. So our example here, again, I want us to simplify. And this time it's going to be the square root of 5 over 11. So our first step here is going to be to separate into two radicals. So I end up with the square root of 5 over the square root of 11. And what's tricky here is it might look like, okay, I did the division property of square roots, but convention says that we need to get the square root out of the denominator. So convention says we do not keep radicals in the denominator. This is because if you end up with square root in the denominator, you have an irrational number that you're dividing by, and that can get super, super messy and confusing. So it's easier to try to divide by a number that has never-ending non-repeating decimals. It gets really, really unclear and gross. So that's why we don't like to keep the radicals in the denominator. So to get them out of the denominator, what we're going to do, step 2, is multiply by the denominator divided by itself, which as a note is equal to 1. So my denominator here is the square root of 11, so I'm going to multiply by the square root of 11 over itself, which is the square root of 11. Again, any number over itself is equal to 1, so I'm not changing the value of anything, I'm just changing the way or the form in which it's written. So when I multiply these, I end up, as we use the multiplication property of identity again, or property of square roots, I end up with the square root of 5 times 11 over the square root of 11 times 11, which that's just 11 squared. So I end up with the square root of 55 over 11 squared. The square root of 11 squared is just 11, so I end up with the square root of 55 over 11, and that's my final solution. So the square root of 55 over 11 is your simplified form, though it may look more confusing because there are more digits. It's actually the simplified form of that radical. So we're going to do a couple of quick checks really fast. I want us to simplify these two numbers, or these two expressions. We have the square root of 6 over 5, and second we have the square root of 7 over 2. So try those on your own, pause it if you need to. I'm going to go over it now. So again, our first step, we separate it into two radicals, and then I need to get rid of the radical in the denominator, so I'm going to multiply by that over itself. So the square root of 5 over the square root of 5, which ends up being the square root of 30 over 5, since the radicals cancel out, end up canceling, since I have 5 square rooted, just becomes 5. So this is my final simplified form of that radical. The next one, we do the same thing. So we have the square root of 7 over the square root of 2. I multiply the square root of 2 over the square root of 2, which becomes the square root of 14 over 2. And we are done. Make sure you write down any questions, comments, concerns, so we can go over them together in class.